Hey everybody. So I'll be telling you about this independent project that I've been running over the past couple of years. It's called privacytests.org, and it's an open source effort to measure the privacy characteristics of all the major web browsers. So in this talk, I want to just give a brief idea of the problem that I'm interested in solving, which is the connection between mass surveillance and web browsers. And then I'll talk a little bit about the design of this project, of the website. And then I'll give some examples of the privacy tests that I'm running and the kind of results that I'm getting. And then I'll close with some of the notable recent progress in browser privacy and what I've learned so far in working on this project. So the problem that I've been interested in for a long time is that the web is a major target of mass surveillance. As we all know, the web is a primary means of modern reading, writing, communicating, and commerce. But for something so important, there's a major compromise, which is that most web browsers are heavily exposing their users to mass surveillance by corporations and governments. As an example, you might have seen this report recently that the US government is buying vast quantities of US citizens' personal data to add to US government databases. And this stunning accusation against the US government was made by the US government. Somehow, commercially available data from cars, phones, and web browsers are extremely important, and they're happy to spend lots of money collecting that. So how is it that web browsers are making this possible for everybody to be surveilled, for us all to be spied on? Well, there's a couple reasons. One is just that browsers are allowing websites you visit to embed trackers, and these trackers can gather your browsing history. And it's built right into the design. And a second thing is that browsers are still not encrypting all of the connections that you're making on the web. They're still unencrypted parts. Finally, browsers are gathering data themselves in large amounts, depending on the browser. But this is fine, right? Well, I don't think so. So the web's been around for about 30 years. Why are web browsers still leaky after all this time? I think there's a few main reasons for this. One is that web browser privacy leaks are very technical, and they're hidden, and they're complicated. So basically nobody, not even people who work on browsers, really knows what's going on. Another issue is that the major web browsers are funded largely by revenue from the top trackers. And finally, there are some legitimate concerns about web compatibility. So historically, at web browsers, by and large, privacy has tended to be a lower priority than you might expect. So I wanted to try to bring some more visibility to this problem. I wanted to see is there a way we can make web browsers more accountable for protecting web users from this kind of mass surveillance. And so this involves, my idea was to try to detect the privacy leaks in web browsers, monitor those leaks over time, and then make the results public to inform users and also browser makers. So there's a bunch of challenges in how to design a site like this. One, as I mentioned, is that browser privacy leaks are invisible. So I decided I needed to make these results public, that was a key part of the issue. It's also very highly technical, so I wanted to try and distill the essence of what was important, so make it as simple as possible, even though it's a very technical thing. Also, to make it valuable information, I thought we need to make it actionable. We need to give users an opportunity to take action, which means that they can, if we compare web browsers, then they can decide which web browser they want to use. So I first thought about doing this in 2018 when I was working at Tor. I started working on it independently in 2021 after I had developed some of it on the side. So I took a break from earning a living and worked on it for a while. I launched it in October of 2021. And I'm still working on it to this day, although I have a day job on the side. I'm working on this project. And so the basic idea is I have a Mac. I run browsers on it. I direct them to certain test web pages. The web pages attempt to do a simulated tracking event, and then they collect the data, and then the data is stored so we can render it into something that users can look at. So this is the pipeline. You start with a configuration file, run the tests, get the data, render it into a page. This page then gets published on the privacytest.org website, and then I share it on social media. And I'm testing quite a long list of leaks at the moment. I'm going to go over some of these just as examples. The first example is state partitioning. So one of the problems that we have is that web browsers allow state or data to be shared between websites. So if you visit website A third-party cookie can be stored, and then when you visit website B, that same cookie can be read back by the same third party, and now the third party knows that you visited both websites. So this diagram shows what Firefox's approach was, which happened a couple of years ago, that instead of having a single cookie jar for third-party cookies, the cookie jar was separated into one for each website, so that cookies were not able to be shared across websites. And this kind of partitioning can be applied not only to cookies, but all kinds of stateful data. So if you look at the test results, right now, Firefox-derived browsers and also Safari and Brave are partitioning, but Chrome and some of the other Chrome-based browsers are not yet partitioning. So they're still allowing this really fundamental kind of cross-site tracking. But Chrome is working on this, and so there is going to be progress, I think, in the coming months. Another thing I'm sure you're aware of is that HTTPS usage has gone way up over the past decade or so. And it's high enough now that it makes sense for browsers to push the use of HTTPS even further than it would happen just according to what websites are requesting. So you can see that Brave is now upgrading all websites that it can. And we also see that LibreWolf, Mullvad, and Tor browser actually will show an error page when you visit a website that doesn't have HTTPS. Another key category that I'm testing is third-party trackers and the cookies and scripts that they would embed in the websites you visit. There's a great survey called whotracks.me. So I borrowed their list of the top 20 trackers, and I am basically testing to see if each web browser will load or block each of those trackers. And the results right now is that a few browsers for desktop, Brave, LibreWolf, and Mullvad are blocking all of those top trackers. The other browsers are not blocking trackers, so they are loading them. More of the browsers are blocking the cookies from those trackers, so you can see that that's a more widespread thing. But there are still some browsers such as Chrome, Opera and Vivaldi, and Edge, which are still allowing tracking cookies. And then finally, one more example, tracking query parameters. These are the parameters that are added to the ends of the URLs you're visiting. This is a way of tracking you across websites that doesn't require cookies. And a few browsers now are blocking or removing those parameters. There's been a lot of progress since I started monitoring all these different kinds of privacy leaks. Notably, there's much more partitioning than there was when I started, and it looks like Chrome is going to basically complete that category, and we're going to have all green in the next few months, hopefully. And then another big bit of progress is the amount of HTTPS that's being used has been increasing a lot. So what have we learned so far from this? I think the first interesting thing is that all three browser engines, Chromium, WebKit, and Gecko, have all substantially hardened the privacy protections in some browsers, which means that there's really no excuse now to say there's some technical reason we can't provide these protections, because all of those engines have turned out to be compatible with that. So I think where there's a will, there's a way. A really welcome thing has been that all the browser engineering teams have been very positive and wanted to communicate about the kinds of tests that are being done. And also, I was very grateful by the community participation. Lots and lots of people are interested in which browser they should choose, and they want to know all about these tests. So it's really exciting. There's lots more to test. This is not a complete set of tests, so I'm hoping to keep working on this until I can nail down everything possible. And I've gotten lots of help from other people with suggestions and bug fixes and so on. So thank you, and yeah, looking for questions.